Greetings everyone. This is the software part of Arduino. Having done the technical part, which is the hardware area, whereby you connect your microcontroller to your breadboard, then using the male wire, the jumper wire, and the LED lights, the light emitting diodes. Now this is the software part of it. Now I will explain each part of this code. So let me zoom it so you can see it very well. Now in this first area, I declared a variable. A variable is a container where you store values. Now this is int. This int here simply stands for integer. So that is the meaning of that int. And wherever you see int, it means that whatever that will come after it must be a number, must not be a decimal like this. It must not have decimal, it must be a number. So I declare int and name it a variable green LED pin. Why I use green? Because this pin is specifically for the green lights, the green LED. And why I use this, there are two ways mainly for naming variable when you're using the Arduino IDE. It is also conversant with other programming languages like JavaScript, Python, C++, Java, and so on. So why the two ways of naming a variable? We have the first one called camel way of naming a variable. You can search online and see a picture of a camel. Camel is an animal. The neck comes down and the head comes up. So that's why when naming a variable, you start it with a small letter, then continue it with a capital letter. So this is what we call camel, C-A-M-E-L. So that is the camel way of naming variable. So, and the other way of naming variable is using the underscore. Like if I want to name this in green, I can use underscore LED and use underscore pin. Remember, if you're naming a variable, let there be no space. What I mean by space is, I will not do like this. If I do like this, it will mark error. You don't give space while generating a variable. You must connect it. Either you connect it with a minus sign like this, or you can use an underscore. But throughout this tutorial, I'm not using underscore, I'm not using line, rather I'm using a camel case way of naming a variable. So I'll clean this one off. So that is what I put here. Why I put 13 here is because when you are done with your hardware connection, the technical part of it, I put 13 here, hoping that my green pin is located in the 13 on the microcontroller. Then my red is also located at the 11, and my yellow is located at the 12. So these are the first thing that you do. You have to initialize. You have to create a variables to know where your pins is. Now you come to the void setup. Remember, you can remove this if you wish. There is what we call comment. Comment is a non-executable statement. Like if I don't want this particular yellow red pin statement to be compiled while running my code, I can just come and put a comment here by typing in a / 2 times 1 2, and that code will never run. That means that this particular line of code will never show in any way I am running it. So that is a comment. A comment is a non-executable line of code or non-executable code. Now I want at the void setup, I will first set up my code and tell my code what I need or what I wanted. Now what you first do is you will write a pin. This is a in programming we call it reserved word. That means it is word or library that are saved already in each IDE that helps the programmer to know what he or she is doing. So this is a reserved word. Reserve, I mean, is reserved word. So it is already in Arduino IDE. So now what am I saying here? I say pin mode, green LED light, which is this green here, output. What does it mean? I'm telling Arduino that this green pin, that LED pin that I have attached to my breadboard, it is an output. And output, I mean, is I'm expecting something to come out of it when I upload my code. If my code is correct, I'm expecting something to come out. I want to see something, which is output. I want to receive something out. And what am I receiving? It is that light that will come out from it. Now the same thing is this red output. Assuming it is the switch, that one that you will press for something to happen. This place will change to input because I will send in signal. But since I want to receive a feedback, so it is called an output. The same thing for this yellow. So I have set up the three of them, telling them that I want to receive output from them. Then we'll go to the next line block of code. Remember, in programming we call this bracket, this one is here and this one here, it is called curly braces. And what does it mean? Curly braces helps you to put in any block of code. What I mean by block of code? Everything that is inside that curly braces are called block of code, and they are all referred to this model, which is the setup. So let me come to this void looping. Normally looping in programming is called repetition. For something to happen, repetition, for something to happen timelessly, unending. It will never stop until you ask it to stop. So loop means it will start from beginning, read. When it reaches the last, it will come back again and start from beginning until you apply what we call break, which means stop. So looping means repetition. Now let me remove. Okay, you have seen what this comment said here. This comment says put your main code here to run repeatedly. So looping means something to run repeatedly. Now I want to declare the looping. The first now says this digital write is a reserved word. I explain what reserved is. They are just keywords that have been attached already on the IDE library. Every IDE I have it. Visual VS Code has it. Python, PyCharm has it. QBasic, all programming IDE all has their reserved word. Now this is a reserved word. It's a digital write, and you put it in a bracket. Now what are you trying to say now? I said the red LED pin, comma, and I forgot something. In every statement, any statement, make sure that when you're done writing a statement, it must end with a semicolon. If it didn't end with a semicolon, that program or that line of code will not compile. Let me show you. Let me just delete this one now. Let me delete it. After I will save and I'll show you, but let me just finish explaining this area. Digital write, red pin, comma, high. Normally in programming or in logic gates, high means on, turn something on, put something on. high means to turn something on, and I ended it with a semicolon. Then delay 4000. This 4000 is like 4000 millisecond, and from our mathematics we all know that 1000 milliseconds makes 1 second. So if 1000 milliseconds make 1 second, then 4000 milliseconds will make what? 4 seconds. So which means this 4000 we put here is 4 seconds. And when you're writing it, you're not allowed to put words, like to put letters. Only 4000 is okay for it, and the computer and the Arduino will know what you are trying to say. Like for instance, if 4000 milliseconds make 1 second, if I put 10,000 here, this 10,000 now simply means 1 minute. Yes, if 1000 is 1 second, if I add another 0, it will be 1 minute. If I add another 0, it will be 10 minutes. If I add another 0, it will be 1 hour. So, but let me make it what it was, which is 4000 milliseconds, which is 4 seconds. Now this is digital write, yellow. Now I have given the computer an instruction, said when this thing starts running, show the red light, and let that red light delay for 4 seconds. When the red light is still on at the 4 second, when it reaches 4 seconds that it has been on, let the yellow also on. That means as the red is still on at 4 seconds, let the red join it and be on. Remember, high means on, low means off. It's either I write high here or I write 1. 1 also means on, 0 means off. Anyhow I want to write it. So I said while the red is still on, remember the red will on at 0 seconds, it will stay 0, 1, 2, 3. At the 4th second, yellow should join it and get on. Then yellow will join it and get on. Yellow will stay for 2 seconds. Remember, as yellow is staying for 2 seconds, red is still on, so 2 of them are now on. Then when yellow has stayed for 2 seconds, meanwhile when yellow is in 2 seconds, remember red was in 4 when yellow joined, and now yellow is in 2, so which means in total red will now be 6. So it is in the 6th second of red that red will now go off. This low now means off. So when the yellow has stayed for 2 seconds, when it joined the red, let red and yellow, 2 of them now go off at the same time. Red will go off low, then yellow will join it and go off low immediately. 0 seconds, which means they won't wait. Immediately they go off. Let green come up. Assuming I put 1000 here, it will mean what will happen here, that when this 2 goes off, it will stay like for 1 second before this one comes in. But I want it, don't wait for, that means I want green not to wait for any second. Immediately the 2 colors went off, let green come in. So that is what I mean by delay here, 0. Then I come here, when that green comes on, which is this high, let that green stay on like for 3 seconds, which is 3000 milliseconds. Let it stay for 3 seconds. When it's done on that 3 seconds, let it go off. And when it go off, immediately it goes off. 0 seconds, immediately it goes off. Let the color go back to yellow. This is just a typical example of how our current traffic light works. So immediately the green one goes off, 0 seconds, which is immediately it goes off. Let the yellow one come in. So when the yellow one comes in, it stays for 1 second and goes off immediately. So this is just a typical example of a traffic light. Now let me run it. When you're done with your code, you will click on this plus sign here to verify if your code was correct, if there's any syntax error or semantic error. When you click on it, now see there's an error. It says compilation error, expected comma or semicolon before int. Before this integer, it is expecting semicolon, which is that semicolon that we omitted here. Let me add it and let me verify again. As you can see, it says error. I don't know where this, okay, this error now is from my own laptop, so it is not, this one doesn't have to do with code, but your code, okay, done compiling, your code was correct. This one has nothing to do with the code, so this one is just my own system issue. Everything was correct. So if you type in your own like this, everything's correct. So I'll make another video on how to use the buzzer and how to use the servo motors. If you're only showing this compilation error exit one, this is a technical issue from the software and not your code. If your code is wrong, it will tell you the place it is wrong. Like now, I have removed the semicolon. Let me run it. If your code is wrong, it will tell you. Now it has highlighted a red background over there, which means that the place the error is. So if your own is showing compilation status exit one, so this one is just from your software. Thank you.